Hello everybody, welcome to my channel Circuitry Simplified by Dr. Shobha Nikam. Before we start this video, if you feel contents of this channel are really useful, if you feel the concepts are explained in simplified way, then please subscribe to my channel. Also share these videos with your friends and let me know in comments if you want me to create video on any particular topic. In this video, we'll talk about modeling styles used in VHDL coding. So very first, we must know what VHDL is. So VHDL is a programming language. It is hardware description language. So here V stands for very high speed integrated circuits hardware description language. VHDL code is divided into three parts. First part is library, then comes entity, and then comes architecture. So in library it allows the specific data types or functions to be employed in the design. All those functions, data types, whichever you'll use in your code, all of them are defined in library and packages associated with that library. Next comes entity. In entity, we consider our system as a black box. Then in entity, we define how many inputs are there to our system, how many outputs are there. We also define how many bits are there for input, how many bits are there for output. So library, where the packages are associated and meaning of keywords, data objects, data types, everything is stored. Entity is where we define inputs and outputs to our system. Externally available inputs and outputs. We do not consider intermediate inputs and outputs. Next comes architecture. In architecture, we describe how our system actually works. So to describe how our system actually works, there are four modeling styles present. Basically, there are three modeling styles: data flow, behavioral, and structural. But then combination of these three modeling styles is our fourth modeling style, and that is mixed modeling style. So here we must know levels of abstraction. Levels of abstraction means in how much detailed the system is explained. So here in case of structural modeling is it has lowest level of abstraction. Lowest level means we go to components level. How many components are used, which components are used, that is our structural modeling. Then comes intermediate level of abstraction, and that is data flow modeling, in which we describe how data flows from one register to another register. Then comes highest level of abstraction. In highest level of abstraction, we only explain behavior of our circuit. We do not concentrate on the internally used components. That is the highest level of abstraction. So lowest level of abstraction is structural modeling, where we describe each and every component used. The intermediate level is data flow modeling, and behavioral is highest level of abstraction. To write code using data flow modeling, we can either use Vhdl statement or with select statement, whereas in case of behavioral modeling, we can either use if-else statement or case statement. And in case of structural modeling, we use component declaration. So here, very first modeling style is data flow modeling style. For the sake of understanding, I have used 4:1 multiplexers example, and I have shown implementation of 4:1 multiplexer using all three modeling styles: data flow, behavioral, and structural. So what comes first is library. So library, IEEE, and these three are packages. Use clause is used to include packages: standard underscore logic underscore 1164 dot all, then standard underscore logic underscore arith dot all. It is related to arithmetic operations. Then standard underscore logic underscore unsigned dot all. Here standard logic is a data type which is similar to bit logic, but in bit logic we have only two logical levels, 0 and 1. Whereas standard logic consists of 9 different logical levels, because it is not possible that voltage is always 0 volts or 5 volts or 3.3 volts. There can be variations. So for variations in input voltages and output voltages, we must consider different logical levels. And that's why instead of using bit logic, we use standard logic. Then comes after library. Second part is entity and third part is architecture. In case of VHDL coding, you must write code in these three parts. So library will remain same. Library and packages will remain same for every code. Whichever code you are writing, you will have to write these 4 lines. Next comes entity. In entity, what we define is how many inputs are there, how many outputs are there. So here what we are describing are hardware. So hardware has what? Input ports and output ports. So here entity, syntax for entity is entity. Entity name, so I have given name as mux4_1. Here rule is for entity name or for architecture name must start with alphabet. It can be followed by numbers, and only one special character is allowed, and that is underscore. So entity name is port. Here you can see in this diagram 4:1 multiplexer. How many inputs are there? 4 inputs, A, B, C, D. So port A, B, C, D, colon, they are inputs. So in, and their data type is standard logic. Then in case of multiplexer, what we have is select input. So for 4:1 multiplexer, number of select lines are 2. The relationship between select inputs and data lines is 2:m is equals to n. So S, this is also input. So in, when number of bits are 2 or more than 2, then instead of writing standard logic, what we write is standard logic vector. And here length is 2 bits. So 0 to 1, or what we can write is 1 down to 0. S0 and S1 are 2 select lines. And Y is our output. Out, standard logic, bracket complete and semicolon. Now we are done with all inputs and all outputs. End, entity name. Our entity's name is mux4_1. So end mux4_1. So this is all about entity declaration. Next part is architecture. So entity for 4:1 multiplexer will remain same for all 3 modeling styles. Library files will remain same for any VHDL code. Whereas entity for 4:1 multiplexer will remain same for any modeling style. Then what changes is architecture or modeling style. So here I'm writing this code using Dataflow modeling style. So what I will write? Architecture name. For sake of understanding, I have written Dataflow, but instead of Dataflow, you can assign any name to this modeling architecture or this modeling style. Architecture, I have given architecture name Dataflow of. I'm writing this architecture for this entity. So I must mention here entity's name of mux4_1 is. Here architecture begins. Then as already explained, in case of Dataflow modeling style, we can either write code using when else statement or with select statement. So here I have taken example of when else statement. So architecture begin. Here y is what? My output. So y is assigned as a. When it is a, when S0 is 0 and S1 is 0. It means when S is 0, 0. Y is assigned as A when S is equals to 0, 0. Else B. But when B? When S is 0, 1. Else C. When it is 1, 0. Else it is D. Y means my output. End architecture name. In this way, we write VHDL code using data flow modeling style, either using when statement or case statement. You must remember data flow modeling is concurrent modeling style. It means whatever statements, whichever statements will write in architecture, all of them will execute parallelly. After data flow, next is behavioral modeling or sequential modeling. Here what we use is sequential statements. So statements written inside process or inside function or inside procedure are sequential statements, but you need to remember process, function and procedure, all of them are concurrent. It means if I'll write 10 number of processes in my one code, all 10 processes will execute parallelly. But inside every process, execution is sequential. That is, one statement will execute, then second statement will execute, then third statement will execute, and so on. Variables are allowed in behavioral modeling, and statements allowed in behavioral modeling are if else, case statement, wait statement, loop statement. These statements are allowed in behavioral modeling. So here you can see same 4:1 multiplexer is explained using behavioral modeling style. Library files are same. Entity is also same as data flow modeling. Next part is architecture, that is different here. So architecture name behavioral. I'm writing this architecture for this entity. So entity's name begin. In case of behavioral modeling, this is sequential modeling style. So it is mandatory to use process statement because inside process execution is sequential execution. So process in bracket sensitivity list. So here in sensitivity list we must include inputs to which our process is sensitive. Sensitive means when value of these inputs will change, my output will change. So here how many inputs we have? A, B, C, D, 4 data inputs and 1 select input we have. But here I haven't included A, B, C, D. I have only included S because even if value of A, B, C, D will change and if select line will not change, will not get any output. And that is why process is sensitive to select input. Begin. Either we can use if-else statements or case statement in behavioral modeling. So case S is when 0, 0. It means when value of S is 0, 0, my output Y is assigned as A. For 0, 1, B. For 1, 0, C. And for 1, 1, D. When others, then Y is assigned as null. Now you could think, we have already covered all conditions 0, 0, 0, 1, 1, 0 and 1, 1. Then what else is remaining? So here our data type is not bit. Our data type is standard logic. It means it does not have only two values 0 or 1. It has 9 different logical levels. So combinations can be 2 raised to 9 number of combinations. So for all other combinations, output Y is null. End case, this case is ended here. End process was started here. End process, and before that architecture was started. So end architecture name, that is behavioral. Next is our structural modeling. In structural modeling, we go to lowest level of abstraction. It means we must know how many components are used, which components are used. So based on this truth table, I have written equation for 4:1 multiplexer. It has 4 inputs A, B, C, D and it has 2 select lines S0, S1. So here for first condition, value of S0 and S1 both are 0. So equation is S0 bar S1 bar A plus S0 bar S1 B plus S0 S1 bar C plus both are 1. So S0 S1 into D. And for that we need 4 AND gates. First AND gate, second AND gate, third AND gate, fourth AND gate. And all these 4 AND gates are 3 input AND gates. So you can see 1, 2, 3, 4, 4 AND gates, 3 input AND gates. Then for performing addition operation, we must have OR gate. So this is our OR gate, 4 input OR gates, 1, 2, 3 and 4. And to get S0 bar and S1 bar, we must have 2 inverters. So total 7 components are used. 4 AND gates, 1 OR gate and 2 inverters. Let's see how to write code using structural modeling. Now you know structure of 4:1 multiplexer. Library files will remain same and entity will also remain same. Now let's see an architecture. Now let's see how to write an architecture. So architecture name of entity name is, before we start this architecture, before begin statement, we must define all the components, whichever components we are going to use here. So which components we are going to use here? Inverter, AND gate, though they are multiples, but one AND gate having 3 inputs, inverter and 4 input OR gate. So component inverter. In case of inverter, there is one input and one output. So X in standard logic, Y out standard logic, and component. Next is 3 input AND gate. Component and 3 is port ABC are 3 inputs. These are imaginary inputs in standard logic. Y is our output for this AND gate. Next component is 4 input OR gate. So component OR 4 is port. This declaration is very much similar to our entity declaration. Port ABCD in standard logic, Y out standard logic, end component. Now next part is, in entity what we define? External inputs and external outputs. But here we have intermediate wires, Y1, Y2, Y3, Y4. Then here outputs of these two inverters, S0 bar, S1 bar. So we must define them as a signal. So signal S0 bar, S1 bar, Y1, Y2, Y3 and Y4. And their data type is standard logic. Begin. Then my first component is inverter. So my input to my first component, first inverter is inverter port map. Now here you need to write actual inputs and outputs to your system. So input is S0 because I want S0 bar here. S0 output is S0 bar. For second inverter, input is S1, output is S1 bar. Then my first AND gate, what is input? S0 bar, S1 bar into A. So here C3, these are labels, C1, C2, C3, C4, these are labels, colon, names of the components. And then port map, it means I'm writing names of my actual inputs and outputs here. And this is called as component instantiation. First AND gate is port map, S0 bar, S1 bar, A. These three are inputs and my output of first AND gate is Y1. For second AND gate, S0, S1 bar, B and output is Y2. Here it is S0 bar, S1, C and output is Y3. And here it is S0, S1, D and output is Y4. You just need to mention or follow the sequence. Here in AND gate the sequence is C. Input, input, input and then output. So here also you need to write same input, input, input and then output. This is called as positional association. Then for my OR gate, what are my inputs? Y1, Y2, Y3, Y4 and my output is Z. So Y1, Y2, Y3, Y4 and here my output is Z. So in this way, we can write code in structural modeling. Then end, structural. Here begin, then component instantiation, and then end, structural. So in this way, we can write Vhdl code in 3 different modeling styles: data flow, behavioral, and structural. I hope you'll enjoy this video. Thank you so much for watching.